All right, the lesson for today is over the quadratic formula. So this is going to give you guys an additional method for solving a quadratic equation. So first off, let's take a look at the function we are given here. We know that our two methods for solving a quadratic right now, we're going to solve by factoring, or we can solve using square roots. Those are the two methods that you guys are familiar with at this point. All right, so if we take a look at this equation here, because there is an x squared and an x term, I cannot use square roots on this one. I would have to do factoring on this one. And when we're factoring, we have to make sure our equation is equal to 0. So the first thing I'm going to need to do is make sure that I scoot that x squared, because it's negative on the left side of the equation. We're actually going to scoot it to the right side of the equation and make it positive. So I'm going to add that x squared over to the other side. That would give me 0 over here. And then we would have x squared minus 12x plus 6. Okay, because there are 3 terms and we are trying to factor, we now need to do our puzzle. So remember, our product is the number that's on top, so 6. That would be your A value times your C value. Your sum is negative 12. So I'm looking for factors of 6 that would add up to negative 12. And as far as I can tell, there's nothing that is going to work. So this guy does not factor. Or in the past, we have called that prime. However, even though it doesn't factor, that doesn't mean we can't solve it. And again, the whole idea was to solve. So sometimes we try to solve by factoring because factoring tends to be pretty quick, but not all equations, not all quadratics can be solved by factoring. So, and obviously we already said it couldn't be solved by square roots. So our third method that we are learning today is solving using the quadratic formula. So this is method number 3 that you guys should be familiar with from this chapter. Okay, so if A, B, and C are real numbers, and A can't be 0, obviously, because then you wouldn't have an x squared and it wouldn't be a quadratic. The solutions of the quadratic equation, ax squared plus bx plus c equals 0. All right, this is saying we are in standard form. And notice your equation is equal to 0. Okay, very important that that is the setup before you identify your A, B, and C and plug them into the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, that is the quadratic formula. That is something that as you go through and use it or apply it more, you guys should be very familiar with the quadratic formula by the time you're finished with this lesson. So we're going to use it quite a few times today in this lesson, and then as we work through the rest of chapter 4, when we're solving, quadratic formula is always an option for you to solve. So down here it says, let's try solving that equation again. So our first step in using we're going to use the quadratic formula this time. Okay, and we're going to solve by quadratic formula. So the first step is to write the quadratic in standard form. Again, standard form is where you have ax squared plus bx plus c, and you're equal to 0. So when you're using the quadratic formula, just like if you were factoring, your equation must equal 0. So that is our first big thing. Our equation must equal 0 for us to use the quadratic formula. So up here, it doesn't matter if you take this x squared and move it to the right, or if you take these two guys and move them both to the left. What I would suggest, though, is that typically, just like with factoring, we like our x squared term to be positive. So that's why I'm deciding to move my x squared to this side. So when I do that, I'm going to end up with 0 equals x squared minus 12x plus 6, just like we had up above. But now instead of trying to factor it, because we've already decided factoring won't work, we're going to identify the a, the b, and the c. And the a is the coefficient of x squared, b is the coefficient of x, and c is the constant that's by itself. So if you'll notice over here, a is the coefficient of x, which is not written but understood to be a 1. So a would equal 1. B is the coefficient of x, so b equals negative 12. And c is the constant that's by itself over here, so c equals 6. And I always suggest that you guys put it in standard form and identify your a, b, and c before you try to start plugging them into the quadratic formula. So now our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So I'm going to do my best to try to color code these as I'm plugging them in. So everywhere there's a b, I'm going to put a negative 12. This actually says negative b, so that all that means is just the opposite of what b is. So up here, b is a negative 12, which means negative b would end up being a positive 12. So we would have 12 plus and minus the square root of, and we ran into another b. I definitely want to put this one in parentheses, negative 12, because it's being squared. So we want to make sure that anytime we square a number, it comes out to be a positive. So I'm going to put that in parentheses so that if we were to plug that into the calculator, we would get a positive out of it. So negative 12 minus 4 times my a value, which is 1, and my c value, which is 6. And then we're dividing all of that, the whole thing, by 2 times my a value again, which is 1. So again, everywhere there's an a, I'm putting in 1. Everywhere there's a b, I'm putting in negative 12, or the opposite of b, which is positive 12. And then everywhere there's a c, we put 6. And then the last step is just to simplify that down. We're going to clean everything up. I usually start with a square root. So in other words, I want to simplify the stuff that's under the square root first. So we're going to try to clean this up a little bit, the stuff that's under the square root. So x equals 12 plus and minus the square root of, so I know negative 12, once I square it, would be 144. And then this is a negative 4 times a 1 times a 6, so that would make negative 24. All over, and then 2 times 1 would just be 2. And that is equal to, let's keep cleaning up underneath that square root. So 144 minus 24 would be 120, and then all divided by 2. Not quite done. We have definitely been working on simplifying the radical, so I'm going to come over here off to the side and we're going to simplify that down. So I know 120 would have to be 12 times 10. I know 12 is 3 times 4, but 4 is 2 times 2. So 12 would be 3 times 2 times 2 times, I know 10 is 5 times 2. So again, all of these are under the square root. So the square root of 120 is equal to the square root of 3 times 2 times 2 times 5 times 2. And what I'm looking for are buddies. I'm looking for pairs of things because this is a square root. So I have 2 2's here, so they get to come out of the house. Right? Does anybody else have a buddy? So I have another 5, I have another 2, and I have a 3. So nobody else gets to come out of the house. So we have to leave that as 3 and 5 and 2 all inside the house. And anything outside the house gets multiplied together. So there's just a 2 this time. Anything inside the house also has to get multiplied together. So 3 times 5 is 15. 15 times 2 is 30. All right, so that was kind of a little side note to simplify down our square root of 120. So now we can plug that back in. The square root of 120 simplified down to 2 square roots of 30, all divided by 2. Okay, hopefully those steps so far have made sense for you guys. Again, plugging into the formula and then just simplifying down from the formula there. The last thing I need to do is to finish reducing my fraction. And so I have to look at this number, this one here, and this one here. The radical is a different kind of number, so it doesn't relate to these other numbers. If all three of these numbers are divisible by the same thing, we're going to divide them. But it has to be these three numbers. If there's no number in front of the root, it's not reducible because the number in front of the root would be understood to be a 1. So 12 and 2 and 2 are all divisible by 2. So 12 divided by 2 would give me 6. 2 divided by 2 would give me 1. I don't necessarily have to write that 1. And down here, 2 divided by 2 would also give me 1. A 1 in the denominator isn't required either. So to finish writing this answer, I could put 6 plus and minus. I don't have to put the 1 in front of the root. We would leave it as the square root of 30. Okay, what we just found there was the two x-intercepts of this quadratic. Okay, so I'm actually going to hop over to Desmos, and I want to graph those and kind of show you how this relates to what we just found on the graph. So instead of writing 0, I'm going to put y equals, and then our quadratic was x squared minus 12x plus 6. So if you notice, if I can zoom out a little bit, we're crossing the x-axis here, and we're crossing the x-axis here. Well, those decimal values, 11.477, and this one of 0.523, if we were to actually plug this into the calculator, 6 plus the square root of 30 would be approximately 11. 6 minus the square root of 30 would be approximately 1/2. That's this value here and this value here. It's actually easier on the TI calculators because then you type trace, and then you can type in 6 plus square root of 30, and you should get this value. 6 minus the square root of 30, and you would get this value. Please notice that these do represent two different answers. 6 plus the square root of 30 is a totally different number than 6 minus the square root of 30, but we can write it in kind of a shorthand form by putting the plus minus in between them. All right, so our directions here tell us to solve using the quadratic formula. I'm going to write the formula up here at the top again. The more we repeat it, hopefully the more you guys will learn it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so the first thing we need to check is my equation equal to 0, and are we in standard form? Standard form, ax squared plus bx plus c equals 0. And this one is, we're good to go. So let's go ahead and identify what's a, what's b, and what's c. So a equals, remember that's the number in front of the x squared, which in this case is a 1. B is 2. C is negative 3. And then we're going to plug those into our quadratic formula. So x equals negative b. This is what I'm looking at. So b is 2. Negative b is the opposite of that, so negative 2. Plus and minus the square root of b, which is 2, squared, minus 4 times a, which is 1, and c is negative 3. All divided by 2 times a, which is 1. Again, we clean all of that up, starting with what's under the square root. So 2 plus and minus. Okay, I know the square root of 2 is 4. And I know negative 4 times 1 times negative 3 should end up being positive 12. So what's left under the root is the square root of 4 plus 12, which is 16, all over 2. Okay, we need to simplify the radical, and hopefully you guys recognize 16 as a perfect square. So we end up with negative 2 plus and minus. What is the square root of 16? So that should be 4, because 4 times 4 gives me 16. And then all divided by 2. Now, this situation didn't happen last time. Our radical actually went completely away because we had a perfect square here. If that is the case, then you need to go ahead and finalize your answers as two separate values. Because all of these are like values, we can go ahead and combine them together. So we're going to do -2 plus 4 divided by 2. And you do not have to write this part out, but I'm writing it out for you guys so you know where I get this from. And x equals -2 minus 4 divided by 2. And we're going to clean each one of those up. Let's simplify both of those. So x would equal, what is -2 plus 4? That should be 2. What is 2 divided by 2? So x equals 1. And then over here, -2 minus 4 would be -6. -6 divided by 2 is -3. We got two answers again. These two answers just happen to be whole numbers, whereas on the last answer or the last problem that we did, they both had radicals in them. So go ahead and try this one on your own. I'd like for you guys to pause the video, give this one a try on your own, and then come back and check your work. All right. If you're back, hopefully you were successful in applying the quadratic formula on this one. So I plugged in the values and then started simplifying. And if you'll notice, as I was simplifying, we had 4 squared, which was 16. And then I had -4 times 1 times 4, which is -16. So -16 minus 16 gives me 0. So hopefully that didn't totally throw you guys off. You may not have experienced that before, but that's okay for the square root of 0 because the square root of 0 is 0. So we have -4 plus 0 and then -4 minus 0, which is -4 either way. And then you divide that by 2 and we're going to get -2. So this is one of the few quadratics that actually has only one solution at x equals -2. All right, we're going to take a look at the next one together, only because this one does end up giving us a little something different that we've seen in this lesson. So again, first thing I need to make sure I'm in standard form, which this one is not. I need to take that 10 and move it over to the other side. And it's imperative that you do that before you identify your a, b, and c. So this one would be x squared minus 6x plus 10 equals 0. So now I can identify a, b, and c. A is 1, b is -6, c is 10. And we're going to plug that in to our quadratic formula. So x equals -b, which is the opposite of b, so 6, plus and minus the square root of b in parentheses squared minus 4 times 1, which is a, and c, which is 10, all over 2 times 1. Okay, again, working to clean up under the radical first, so we have 6 plus and minus. -6 squared is 36. And -4 times 1 times 10 is -40. So we end up with 36 minus 40, which is -4, all over 2. So this takes us back to what we worked on last lesson, which is complex numbers. So the square root of -4 does give us an imaginary number, and so we do end up with a complex solution for this one. So we have 6 plus and minus. So the square root of -4 would be the same thing as -1 times 4. And if you guys will remember, the square root of -1 comes out as an I. And then the square root of 4 is 2, all over 2. So then we take a look at this value, and this value. Are all three of those numbers divisible by the same thing? Yes, they're all divisible by 2. So we're going to divide by 2, which would give me a 3 there, a 1 there, and a 1 there. Neither of these ones, because this is a coefficient and this is a denominator, neither of those ones is required to be written. You can, but it doesn't, you don't have to. So 3 plus and minus I would be your final answer for that one. Again, two separate answers, 3 plus I, 3 minus I. Two different answers on that one. Okay, so you've kind of seen each of the different scenarios that you could possibly see as far as quadratics are concerned. Over here, you have two actual number solutions, okay? So we call these two real solutions. Right here, you only ended up with one solution, so that has one real solution. And then over here, you ended up with two solutions that both had I, so that would be two imaginary solutions. And I point that out because that's actually where we're headed for the next part of our lesson. So the quadratic formula is pretty useful for something else. In the quadratic formula, the expression under the root is called the discriminant. I think it's A. Apologize if I end up spelling this wrong. I think it's discriminant. Okay, it tells us how many and what type of solutions there will be for any quadratic. Again, this is the expression that is under the root. This guy right here, the b squared minus 4ac. Not the root itself, only what's under the root. This is the discriminant. Okay, so for the next three problems, and that's all we really have left for our lesson today, we're going to, oh, I forgot about this part. Okay, so in the discriminant, when we're using the b squared minus 4ac, there's actually three different things that you could, three different scenarios that you could come up with. The discriminant could be greater than 0, less than 0, or equal to 0. And those are the three situations we're going to take a look at. So when the value of the discriminant, again, the discriminant is just the b squared minus 4ac part, the stuff that's under the square root of the quadratic equation, or the quadratic formula, sorry. When the value of the discriminant, when b squared minus 4ac is greater than 0, okay, greater than 0. What are the numbers that are greater than 0? What are all the different numbers that would be greater than 0? Well, you couldn't tell them all to me, right? But you could tell me that they're all positive, and that's what I would be looking for. So all of the values greater than 0 would be positive. So when the discriminant value ends up being positive, we have two real solutions. That's because the number that's under the root is a positive number. Okay, so what that graph would look like is it would be actually crossing the x-axis twice, here and here. Or we could have like this, either up or down, either one, doesn't matter. So I'm going to do that one like that. So here would be a solution and here would be a solution. Okay, so the graph could open up or down. The idea what I'm looking at is the fact that it crosses the x-axis twice. All right, your second scenario would be b squared minus 4ac is equal to 0. Okay, that was the second situation we had over here. Our discriminant was equal to 0. The number under the root we got was a 0. In that case, we have one real solution. And what that looks like graphically is the quadratic actually bounces off of the x-axis at that particular value. So the x-intercept actually is where the graph touches the x-axis for that one. Sorry, got to get my arrows on the end there. Again, we could have a parabola opening down that would be the same thing. So the parabola opens down and it just goes and it bounces off of the x-axis like that. So again, it's only crossing the x-axis, actually just touching the x-axis, doesn't actually cross the x-axis. And then our last situation would be if b squared minus 4ac was less than 0. So what kind of numbers are less than 0? Well, those would be our negative numbers. So if you end up with a negative, then that means you have a negative under the square root, which means you have two imaginary solutions. What that means graphically is that the graph does not ever cross the x-axis. So we could have a parabola opening up like that down, or we could have a parabola like this opening up like that. But in either case, notice the parabola does not touch the x-axis at all. The solutions are imaginary. You can't actually see solutions graphically. So let's use this real quick and see if we can come up with the discriminant of the quadratic, and then we need to describe. So we need to find the discriminant. So that's just going to be a number, a numeric value. And then you need to describe the number and type of solutions. So that's going to be what I was telling you up here, the number and type of solutions. These are your only three options. So let's take a look. We again want to check and make sure, are we in standard form before we identify our a, b, and c. So we have ax squared plus bx plus c. We're in standard form. We're good. So then we're only using the b squared minus 4ac part. Let's identify our a, b, and c real quick. So I know a is 1, b is 34, and c is 289. So we're going to plug those in just to the discriminant. So b would be 34 squared minus 4 times a is 1 and c is 289. Okay, off the top of my head, I could not tell you what 34 squared is. That's not one I use often, so I'm going to go ahead and plug that guy into the calculator. That ends up being 1156. That was a really ugly 5. Let's try that again. 56 minus 4 times 1 times 289. So 4 times 289, and that is also, imagine that, 1156. So 1156 minus 1156 is 0. The value of the discriminant is 0. That's finding the discriminant. So what does that tell me? How many and what type of solutions do I have? So if you take a look at the chart above, our discriminant is equal to 0, which means I have one real solution. So there is one real solution to this quadratic. And you could check that by graphing, and you should see the graph just bouncing off of the x-axis. Okay, try the other two for me and then come back and check. All right, if you're back, hopefully you recognized on both number 5 and number 6, they were not in standard form to begin with, so we had to move them around a little bit to get them in standard form. I went ahead and moved my 3 and my negative 8x to the left because my x squared was already on the left and positive. You would still get the same value for the discriminant if you moved the x squared over and ended up having opposite signs here from what I had. In either case, you should come up with a positive 76 for the discriminant value, so there are two real solutions. Same concept for number 6. Our b term was on the right, so I moved him to the left, stuck him in the middle, and identified a, b, and c, plugged it in, and we should have gotten a discriminant value of negative 7, which means we have two imaginary solutions. So hopefully all of that made sense as far as using the quadratic formula and also identifying the discriminant, which helps us figure out how many and what type of solutions we have. To finish off the lesson, I'm going to play you guys a quick little song.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.